Alright, so we are back with section 1.3 called Combining Transformations. If you're one of those students who likes to do everything at the end of the unit and slack off and not do any homework for the beginning parts, well, today is not your day. Because today we're going to be reviewing all the stuff you learned in section 1.1 and 1.2 and putting it all together. So if you're clueless right now as to what's going on in 1.1 and 1.2, may I strongly suggest that you go back and watch those two videos before continuing with this one. Did you hear me? Yeah, strongly suggest that you do that. And while you're at it, maybe do the homework or the textbook questions that I assigned before doing this section. Trust me on this, you'll thank me later. Alright, those of you who have done section 1.1 and 1.2, well, the first part of today's notes should be a review. So what happens to the graph of y equals to f of x when we transform it into this crazy looking function? We have a of f bracket b of x minus h, close all the brackets, plus k. So we looked at these variables or parameters a, b, h, and k in the past. Section 1.1 talked about h and k, so let's review. When k is bigger than 0, what happens to the graph? And if you say it translates, that's good. Which way does it translate? And if you said up k units, congratulations, you actually learned something from section 1.1. If k is less than 0, of course this translates not up, but down k units. And the h one, remember, we're looking at the factor x minus h. So when h is positive, that's an example of something like this, x minus, let's say, a positive number 3. This translates, yes, which way? Well, it's a horizontal way. This one goes right h units. While an example of the h is less than 0 would be something like this, x minus, let's say, negative 3. Or that translates or simplifies to x plus 3. And of course, that's translating left h units. Okay? Review of section 1.1, right there. And then how about 1.2? We learned about the parameters a and b. If the absolute value of a, meaning we don't care about the sign, okay? Anything that's negative becomes positive for the absolute value. If that is bigger than 1, what happens? If you said vertical expansion, I like it. And let's further give some more details by a factor of a. Yep. If it's less than 1, we have the vertical compression, still by the factor of a. And what happens if we find that a is negative? That means it's less than 0. Yes, that's where we do the reflections. In this case, it's a reflection in the, remember which axis? If you said x-axis, you are correct. Okay, look back at your notes if you're not too sure why. And then for the b value, we're talking not vertical, but we're now talking horizontal. This one's the weird one. The horizontal stuff is always opposite. So when b is bigger than 1, it's actually a compression. And we're compressing it by compressing it by a factor of 1 over b. Of course, when it's less than 1, we're just now expanding it. Once again by a factor of 1 over b. And when b is less than 0, once again, that's a negative sign. So this is a reflection in the y-axis. All right. So keep that in mind as we do this unit. Now, underneath, you might be thinking, well, what happens if I'm doing all of them together? Remember how we have order of operations for when you add, subtract, multiply, and divide? Well, there's the same kind of idea when we're taking a look at transformations. So to be consistent with the general transformation function, that's this big ugly thing right here. Okay, y equals to a f of b of x minus p plus q. Use the following order when applying the combinations of two or more transformations. And This little graphic, I must give shout out to Miss Lou and Miss Gordon, my math sister and my math mommy. Yes, we have math brothers, sisters, and mums. Don't ask, okay? Just be happy. Here we go. It's something called BERT, and really, if we're looking at doing transformations, we always start out with a basic function, whatever it will be, like the regular one, and then the E stands for do the expansion and compressions, or what we call the stretches. Do that first. And then afterwards, if you could apply the reflections, just save the translations to the end. Okay? You follow this order, nothing will go wrong. You don't follow this order, can't tell you what might happen. All right, so BERT. Maybe there'll be an acronym for Ernie later on. I love Sesame Street. Do you guys still watch Sesame Street? Bert and Ernie. Okay, let's do some examples here, please. I'd like you, for example number 1, to rewrite the corresponding equation of the function y equals f of x after you do the following things. Well, you're horizontally expanding it, I think, by a factor of 3. You're vertically compressing it by a factor of a half. You're reflecting it in the x-axis, and then you're translating it 2 units down and 4 units to the right. So ultimately, I want you to fill in the values for a, b, h, and k. Well, this idea of expanding horizontally by a factor of 3, which parameter does that affect? Yes, it's the b, and remember in this case, it's always opposite of what you think. It's going to be 1/3 is the number. When I ask you to vertically compress by a factor of 1/2, the parameter in question here is a, and in this case a just equals to a half. If I now ask you to reflect in the x-axis, well, what parameter am I looking for here? That actually replaces the y with the variable negative y. So you're going to be replacing it there. And then translating it 2 units down and 4 units to the right, well, I think that's the h and k. So there's my k value. Here's my h value. So let's put this all together. We got y. Oh, wait a minute. It's negative y equals to the a value, f of b, x minus 4, because I'm going 4 to the right, and then 4 units down means, 2 units down means I go minus 2. Now, most people will not like this as your final answer because that negative is on the left-hand side. Please then move it to the right-hand side. And so if you wrote down something like this, y equals to negative 1/2, f of 1/3, x minus 4, close the bracket once, close the bracket twice, minus 2, that would be the correct answer. Okay? Example number 2 says, given these equations, and you'll see the step-by-step change of the equations, I want you to actually describe what transformation occurred going step by step. Alright, so comparing with the original function y equals x cubed, I have a negative outside the entire function x cubed. That negative, of course, represents a reflection, and because it's outside, it's a reflection in the x-axis. Okay. Then I see this 2 pop in front of the actual function. Okay. In front of the actual function means it's the a value. So in this case, I believe we have a vertical expansion by a factor of 2. Now comparing that to the next one, I've got this 5 that appeared in front of the x. Now notice this is inside the bracket, so it's inside the function. So this 5 actually represents the b value next to the x. Of course, the b value represents something that is horizontal. And in this case, a horizontal compression. Remember, horizontal is always opposite. By a factor of 1/5. And now the next one I see, I've got the x, and I've replaced it with x minus 7. So this is a translation. We're translating 7 units, and this is to the right. And finally, the last one, I see a replacement of y with y minus 10. Now, sometimes more commonly, the negative 10 is put onto the other side. And if you're one of those people that like that, then go ahead and move it. So this represents a translation of 10 units going which way? Yep. To the up. How about just units up? All right. Well done. I'm going to switch it up on you this time. Let me tell you the transformations in words, and now you come up with the equation. All right. This one's probably a little bit harder, but nonetheless, I think you guys can do this. Okay? And by the way, when we do these examples, you can always pause and try them out yourself first, and then come back and check the answers. Actually, that's probably a better way of doing it than just listening to me blah, 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 blah. Okay? So, are you going to take my advice? If you do, pause. If not, well, I can't stop you because I can't see you. Here we go. Let's reflect something in the y-axis. Well, remember, when we reflect something in the y-axis, we're taking the x value and we're making it negative x. So here we go. Then it says expand vertically by a factor of 3. That means my a value now becomes 3. So I will put a 3 in front of the entire function. Because I expand horizontally by a factor of 2, that's my b value, and that actually is a half. So once again, I'm continually building the function. When I translate horizontally 4 units to the left, the x becomes x minus 4. So how about something like this? Notice I put brackets around here, okay? Brackets are important. And then translating vertically 5 units up, you can write this as y minus 5, like this. But most people don't like it that way. So what do most people do? They will bring the 5 over, or the negative 5 over to the right-hand side. This is probably the more popular answer, and this is probably what I would write down on my test if I ever had a test. And there you go. Ta-da! How are you feeling so far? Feeling good? All right, let's do some more examples. We're flying. Okay. What happens if I don't give you the equation, but I give you one particular point? And now I'm going to ask you to track a point on the function. And after all these transformations, tell me what happens to this point. And in the end, what will this point actually be? So I've randomly chosen a point 4, negative 1. And let's do the following now. Let's reflect in the x-axis. Now, when you reflect in the x-axis, think what happens. What value changes? Is it the x value that changes or the y value that changes? And if you said the y value changes, you're right. The y value becomes negative. So 4 stays the same. But the y value becomes negative. Negative of negative 1 is positive 1. Compressing horizontally by a factor of 3/4. I'm now affecting which variable? Horizontal, yeah, it's the x. So I'm going to multiply the x by 3/4. What's 3/4 of 4? That is 3. The y value stays the same. Expanding vertically by a factor of 3. That's where I take y and I replace it with 3y. So now the x value stays the same, but my y value changes. It changes to 3. Then I translate horizontally 8 units to the right. So my mapping notation means that I go x plus 8. By the way, this is mapping notation, okay? You don't need to write that down, but for those of you who like it, you can use it. For those of you who don't like it, don't use it. So 8 units to the right, 3 plus 8 is 11, so 11 comma 3. And then lastly, we're translating something vertically 5 units down, so 3 take away 5, of course, is negative 2. And there we have it. Ta-da! Our point that started at 4 comma negative 1 is now 11 comma negative 2. Right. Let's go ahead and try example 5. Here I'm giving you a different point, 5 comma negative 2. It's on some other graph, some function we don't know about, but that's okay. And I'm going to ask you, by looking at the points, can you identify the reflection and stretches that happened, and then the translations that followed? This one's probably a little bit more tricky. So let's take a look together. See how the 5 became negative 15? That means you multiplied the x values by a negative 3. A negative. Oh. You replace x with negative x. That's some sort of reflection. A reflection in which axis? Yeah, the y-axis. Good. That 3, though, times everything by 3, so x became 3x. That sounds like a stretch to me. So here we got a horizontal expansion. By a factor of 3. Okay. And then I look at the y variables, and it looks like I multiplied by a half. So I think that means y became 1/2 y. How about a vertical compression by a half? Okay. Well, this is an extra bit. If I were to write the equation down for you, okay, and this is extra, I didn't do this in your notes, but I'm feeling like I want to give you some more. It'd be y equals to, and it's the vertical compression factor of a half. I am also going to be changing the b value. So the b value is 1/3 x. And because I reflected in the y-axis, I changed the x component. I need to put a negative in front of the 1/3. And then continuing on now, what's the change between negative 15 and negative 19? How about going 4 to the left? And then from negative 1 to 7, looks like I'm going 8 up. And so looking at my equation now, f of negative 1/3, and notice I bracketed 4 to the left. Left is plus, by the way. And then 8 up. There you go. Example number 5 with some bonus info. Now, why did I do that equation? Because guess what I'm going to ask you to do in example number 6? Yeah, come up with some equations. So once again, my advice to you, try it out on your own first, then come back, double check your answer with mine, and hopefully your answer's the same as mine. So look at all that stuff. That stuff already gives me this. 1/2 bracket 1/3 x all squared. There's a reflection in the x-axis, so that becomes negative. Okay. After the translation, look what happened here. It went 4 to the right. And then I think 5 down because, oh, sorry, not 5 down, 5 up. And so that changes my equation to look like this now. Ta-da! Okay. Try the next one. Oops, what am I doing? It's not even the square function, it's the absolute value function, so I guess I can put the absolute values here. Then we're looking at the 1 to 4, that's add 3, so 3 to the right, 8, 3, 5 down. So y equals to the 2 times the absolute value bracket of -4, and bracket now, once again, x minus 3, close the bracket, close the bracket, close the absolute value, go 5 down. Okay. Last one's yours. No help from me. I'll be silent. Shh. 7 left, x plus 7, 1 down. Did you get that? Let's celebrate if you did. Yay! Alright, enough celebrating. We got more to do. Not too much more, but we still have more. Alright, here's a general rule. If you like rules, great. If you don't, then just ignore this, because if you understand that other stuff, like I said, I think understanding is the key. I don't want you to memorize rules, but for those of you who don't understand and you really need to memorize, then okay, here's a rule. What I'm saying to you is if you've got a function y equals f of x and it undergoes a whole bunch or a series of transformations to become the new function, and this is the new function with all those a's, the b's, the p or h, okay, q. Sometimes we use h. Sorry. Well, then any point xy on the original graph is mapped onto the new point, and notice what happens. That b value is that factor, so it's 1 over b. It affects it affects x, okay? And the h is the parameter that shifts it left or right, so that affects the x as well. That's why the b and the h correspond with the x. And then the a is the vertical expansion or compression of the y, and then the q is the translation up and down, so that's why they affect the y. So ultimately, your x becomes, maybe this is what I'll do, your x becomes 1 over bx plus h, and your y value becomes ay plus q. That's what it's saying. Okay? One more example with the actual function equation that I'd like to show you. This is a particularly nasty example. Nasty. Would I put something like this on your celebration of learning? Is Mr. Lee nasty? Don't answer. Okay. So here I've got a whole bunch of transformations. And the question is by the way, this should be translation. It should be what transformations occur. Okay? Here's what most people do. Oh, I see a negative in front of the x. Oh yeah, that must be a reflection, and because it's next to the x, it's a reflection in the y-axis. Cool, cool. Oh, I see that 3. Well, that's in front of the x, so it's a horizontal compression, right? It's always opposite. And the factor is 1 over b. And then the plus 6, well, that's involving the x. That means you're going to the left 6 units. Where's the problem? Let me go back to that general rule. I'm going to highlight this. You see how involved that x is? It's kind of inside a whole bunch of brackets. Well, you need to actually separate it to make it look like that, to make it look like these individual pieces before you can actually identify what in the world is going on. So may I suggest you, before you do all that stuff, okay, to factor first. Okay. Is there anything that can be factored from the negative 3x plus 6? This is elementary factoring, so I hope you do know that you can factor out the negative 3. And if you do that, what's left over? What's 6 divided by negative 3? Yeah, that's negative 2. So what's left over is this bracket x minus 2. Now, looking at this, you should be able to tell me what is going on. And I'd say to you, yes, there is still a reflection in the y-axis. Yes. And I'm saying to you, yes, there is still a horizontal compression by a factor of 1 over b. But what I'm telling you is, no, you did not go left 6. But what you actually did do was you went actually right 2 units. Okay? So when you identify these transformations by looking at the equation or the function notation, please, please, please remember to factor everything out. Okay? All right. You're thinking, Mr. Lee, we haven't done some graphing yet. Oh, I know. Turn to your last page and let's do some graphing. Okay. So, in example number 8, wow, there's lots of examples in this section. Example number 8. In this diagram, we've got y equals f of x, and that's the solid line wavy equation. By the way, we'll look at more wavy equations in chapter, I believe, 4 or 5. I'm going to ask you to write the equation of the function defined by the broken line. So I hope you can kind of see that the function that's in the broken line is very similar to the solid line, but some stuff has been done to it. We've transformed it. The question I have for you is, how did we transform it? And once you find that, can you rewrite the actual function in function notation? So I'm going to let you try this. Pause it, please, and see if you can figure this out. Okay? Come back when you're stuck, as I'm going to now explain what is going on. Well, a lot of times I'm thinking, you see how this is 1 and it looks like it went doubled? So if I were to take that original solid line, just double it, I think I get this. So if you think about what I did in that blue, I've actually created a vertical expansion by a factor of 2. Well, that's almost like the dotted line. At least the shape is there, but it might not be in the right position. So if I were now to take the blue line and actually shift everything 1 to the right, I think I now have a translation 1 to the right. And if I do that, I believe it matches up the dotted line. So what's the actual equation given these two things? Well, vertical expansion by a factor of 2 means you replace or you put a 2 in front of the f of x function. A translation 1 to the right means you go x minus 1. And that would be a very correct answer. Now, some of you will be thinking, Mr. Lee, why did you choose to go right 1 unit when perhaps you could have done this? You could have moved this point 1, 2, 3 units to the left. So this could have been also a translation 3 to the left. And if you did this, you would also be correct in this case. So 2 possible answers. Still a vertical expansion by a factor of 2, but in this case translating 3 to the left, this is also okay. Because of the nature of the graph given to you in the solid line, how it repeats itself, you'll have multiple answers when you shift things left and right. Okay. Like I said, more of that kind of stuff in Chapter 5, but nonetheless, you got a flavor of it today. Here we go. Here's the last one. We're on the home stretch. Here, I'd like to show you that I've given you the graph of y equals f of x, and I'd like you then to actually, on the other 3 grids provided, sketch out what the graphs look like after the following transformations. Now, the transformations are given to you in that function notation, so you're going to have to identify that first. I like words, so I'm going to write down the words first, and then once I've got the words down, then let's go and shift or stretch or reflect the graph. What do you see in A? That 2 represents a vertical expansion, you bet, by a factor of 2. So we do that first. That means my y values are doubled. Oops, that's not a double. Undo, erase. Doubling 3 becomes 6. So notice, you see what I'm doing? And then these all stay at 6. But then, of course, there's that x plus 3. That means I'm shifting it 3 to the left. Which means this point is 1, 2, 3. This point moves 1, 2, 3. This point moves 1, 2, 3. And the rest stay that way. 1, 2, 3, 1, 2, 3, 1, 2, 3. Ta-da! You're done. Okay, give coordinates for 3 points. -6, 4, -4, 0, -1, 6, and I'll just pick a point over here somewhere. How about this one? 4, 6. Okay, try part B on your own. Some of you don't like that -2 there, so you'll write it like this. That's perfectly fine. I see here a reflection in the x-axis. I see here a horizontal expansion by a factor of 2. I see here moving up 2 units. And remember the acronym BERT, so I will do the actual expansion first. I'm going to expand all the x values by a factor of 2. See, this x value here is -3. By expanding it by a factor of 2 becomes -6. So the y value doesn't change, but the x does. 0, well, doesn't change. Here's 2. 2 times 2 is 4, so this goes over here. So I hope you can see how I'm stretching this graph horizontally. Okay. Then I need you to reflect it in the x-axis. So reflection means take all the y values and make it negative. That's 3, -3. Here we go. And then last but not least, go up 2 units. So I'm going to take every unit or every point, go up 2, up 2, up 2, up 2, connect the dots. There you go. Some points then. How about -6, 0? How about 0, 2? How about 4, -1? And this one, for good measure, 8, -1. Ta-da! Alright, the best is for the last. I'd actually ask you to take a break. This has been pretty long, so maybe take a quick 2-minute break, a quick stretch, then come back and finish off strong. This one is really, really tricky. Why? Well, first of all, on this side, I'm going to ask you to factor. And actually, on the right-hand side, you can also factor. Now, notice the x usually comes first, so I'm actually going to factor out not just 2, but -2. And then you're left with, I think, 2 divided by -2 is -1. -2x divided by -2 is positive x. That looks a little funny, so some of you will write it like this. 2 bracket y plus 2 equals f of -2 x minus 1. That still looks funny because you don't have y by itself, so many of you will divide both sides by 2. So you get a half f of negative 2, x minus 1. Okay. And that still looks funny because you have the plus 2, so this is probably the best looking way. And this is the best looking form to help you identify all the transformations inwards. How about the following? Vertical compression by a factor of half, reflection in the y-axis because it's next to the x, a horizontal compression by a factor of a half, 1 to the right, 2 down. Okay. Once you do enough, you'll be as fast as me, and that's why I'm going to ask you to make sure you do all the homework that I assigned you in the textbook, please. Here we go. So, what do we do first? BERT. B is the basic, it's already there. Expansion compressions. I've got compressions galore. I'm compressing it vertically by a factor of a half. I'm also horizontally, I'm going to do this both at the same time now, horizontally compressing. So this point here goes down to 1, but I'm also compressing to a half. 0, 0 stays the same. This point 2, 3, 2 becomes the 1, the comma 3 becomes 1.5. So here's what I've got so far. And then I believe it's like this. Okay. Then we take a look and tackle the reflection in the y-axis. So take it down, take it down, take it down. Then last but not least, 1 to the right, 2 down. So 1 to the right. This is like half, so be careful. Oops, I forgot to go 2 down. So forget drawing that x there. 1 to the right, 2 down, 2. So here's my new x. 1 to the right, 2 down. 1 to the right, 2 down, 1, 2. And there you go. Okay. Some points, sure. How about this one, negative 0.5, negative 3. This one here, how about 1, negative 2. This one here, how about... what is that? 2, negative 3.5. And all these other ones are just like 6, negative 3.5. Alright, long section. Hopefully not too confusing. Spend some time working on the textbook questions. You need to spend some time, especially for this section, please. Do this well. When we repeat this stuff again in next subsequent chapters, life will be easy.